We are now going to take our newfound knowledge of loops in Python and we're going to use it to move some of our objects across the screen. So to start with, we're going to create a new program in GlowScript. And for now, name it Moving Ball. We'll start with that. So take a minute and create a track that is at the origin and has a length of 3 meters, a height of 0.05 meters, and a width of 0.1 meters. So to make this, you're going to use a box and you're just going to kind of change its vectors. Now notice that the y vector is a little bit below. And so what this is going to do is it's going to let us place a ball at y equals 0 so that it appears to be on top of the track. So these are some suggested lengths. You can change it. You can change the color. You can change how long it is. It's kind of up to you. But if you keep these particular numbers, you're going to be able to follow along fairly well. So then we're going to create a ball. So we're going to use the sphere object at the position of negative 1.400 meters. Now you can change the radius of your ball. You can make it bigger, smaller, but you want it to look like it is sitting on top of the track. So you should have something that looks like the picture here. So you've got this nice long floor, and then you've got a ball that can move across there. Again, you can change the color. You can change some things about it if you want. Just kind of make it yours. So what we're going to do is we're going to move the ball by updating the position of the object. And remember, this is called velocity, right? So as we're changing our position, we are moving with some velocity. And we can make the velocity an attribute of the ball. So remember, an attribute is just a property of our objects, right? So we can change some things about it, and velocity is one of those things. To do this, we're going to call it ball.v. So we have named our sphere ball. And so ball.v is representing the velocity of the ball. So assign this particular velocity to your ball. Now look at this vector. We have a vector of 1, 0, 0. How do you think the position of the ball is going to change? What part are we changing? So remember, the velocity can have different directions, and those directions are going to be in the same dimensions as our positions. So remember, we have x, y, and z. So x is going to be left to right, y is going to be up and down, and z is going to be back and forth. So looking at this vector, we have 1, 0, 0. So 1 means that we are going to move the ball 1 meter per second in the x direction. And it's positive, so it's going to go forward or to the right. Now to make an object move, we're going to update its position at every dt seconds. Now we looked at that little triangle, that delta, the other day. Delta t means the change in time. Now remember, we called this the tick when we did our buggy lab. So delta t in Python is just the time step, or how often the program updates. So dt 0.01 is a good place to start. You can adjust this if you want to change how your ball moves. But for now, change it put it in at 0.01, and you can change it to see what happens once you get your program running. So below your ball attributes, you're going to put dt equals 0.01, and that's the time step. Now, this is going to be how often your program updates. So if you make this really, really tiny, your program is going to update really, really quickly and maybe crash your computer. So you have to be kind of careful with how fast your processor is. It depends on how quickly you can update your program. And we're going to start at t equals 0, right? So time equals 0. So that's where we're going to start. So we're going to start counting at 0. And we're going to update it every 0.01 ticks. So starting at time 0, that's at t equals 0. Forgot to put that. All right, now when you move the ball, you are actually updating the position of the object. How do you find the new position of the object? We've kind of talked about this when we talked about our buggy lab. So the next x, the next position, equals the current position plus your change in position, right? And your change in position, like we looked with our velocity time graphs, is our velocity times the time. So what we need to know where to put our ball next, is where we are right now plus our change. But now we need to translate this into computer speak because our computer does not understand this at all. So the next x is the position of the ball. So this is a new attribute. This is a new property of our ball. And so we're going to call it ball.position. So ball.pos. So the next position is going to be equal to the current position. So the position of the ball right now. And we're going to add the ball.v, which we just defined as 1 in the positive right direction, positive x direction, times our change in time. So we're just taking those things that we've talked about in our lab, and we're translating them into computer speak. All right. So what this looks like then, this is what we have right now, right? We have our now defined all of our initial properties. We have a ball, which is a sphere that's blue, and we have a velocity assigned to our ball, and we've updated our time. So now we're going to add a loop that changes the position of the ball. I don't know what that thing is. I'm not sure what. Oh, I do know what that is. Never mind. Okay, so while the time is less than 10, so our computer is going to start counting, and it's going to count the time. Then while it is less than 10, we're going to count at a rate of 10. And again, you can change this, but you have to be careful with it. The position of the ball is going to be updated as the position of the ball currently plus ball.v times dt. And I apparently typed in velocity there. That's why that little blank is there. So ignore everything behind the curtain there. So ball.pos equals ball.pos plus ball.v times dt. Now we also need to update our time. So time equals the current time plus the change in time. So this change in position is actually happening in a while loop. So run your program and see what happens. And here's what I want you to do. There will be a couple other assignments posted in Classroom, but this one right here, I want you to create a scene that includes at least a ground and your object. You can have more than one thing, and you can change it from a sphere to a triangle. I don't really care what you make it into. And then you want to program the object to stop when it reaches the end of the ground. So that's your goal. Start your ball moving and have it stop at the end of your ground.